Assalamualaikum and good evening. Before we begin, I would like to thank our lecturer, T.S. Muhammad Haria bin Osman. Today, we would like to present our project on milling programming. Next. This is our group member. First, Fahrul Hidayat bin Suhaimi. Next, Syahir Muhammad bin Johari. Then, Afiq Syamil bin Zainabidin. And last but not least, Muhammad Azim bin Zakaria. For the objective of this program is design, robotic and manufacturing process have led to a significant increase in the automation of automotive production. Other than that, the objective of this project is also to demonstrate ISO programming for milling in using rapid traverse for positioning. In addition, to understand and able to explain the concept of the rapid traverse and linear interpolation. Movement system with speed in more details. Manage production by using CNC machine to produce components. For the introduction of this project, milling is a machine process which employ rotating multifunction, multi-point cutting tools to remove material from the workpiece. In CNC milling, the CNC machine typically feeds the workpiece to the cutting tool in the same direction as the cutting tools. In the milling, we use a two-axis milling machine can cut holes and slot in the X and Z axis. In other words, this machine will only cut vertically and horizontally, but only in one direction. A three-axis vertical mill means that the table can move in two directions, which is X and Y. This enables positioning the workpiece relative to the cutting tools while the distance remains the same, so that the third Z axis is added by allowing to the lower of the cutting tool.
Part choosing for this project, an exhaust flank is a piece of metal that bolts directly to the engine of your vehicle and allow for custom headed to the fabricated. They still require an exhaust casted between the header flat and the engine head. An exhaust fan is generally built to match the part shape and size for each application, along with the bowl, hole spacing, and the pattern to allow for a good fit and seal against the engine. A lot of flanks are made to be used with a rubber gasket as the flat is tightened into place with the rubber gasket. The flat squeezes the rubber. Once the rubber has been sequenced, it creates a seal between the exhaust pipe and manifold.
Okay, for the drafting and design process, the first process is we design or sketch our own exhaust flange with dimension found in the internet, and we also changing a few dimension and redesign for ideal and suitable. Next, as you can see, the left picture is the producing the part using CATIA V5, which is consists two types of commands such as pad and hole. And then the drafting process become faster and more accurate using this CATIA software. And you can see the right of the picture is the drafting part is produced, which is we create a stock block for the next process, which is a prismatic milling. From here, we can produce simulation for cutting process and also can produce NC code. Next. For prismatic milling CATIA V5, on the right side is the command for prismatic machining that was produced that contain prismatic roughing using end mill diameter 16 mm for the first process, and also in the process include finishing cut, which is 1 mm to get the surface smooth. Next, we use the center drill, diameter 2.5 mm to spot the center of circle to get much easier to drill. And you can see the back. Okay, and you can see the right of the picture shows the whole project after the finishing the cutting process. Next. Then green one is the waste of the tool in the simulation of the cutting process. Next. And then this is the simulation using CATIA V5. For the first step, we using NMIL 16 and create the roughing process. And then cut the 1 mm for the finishing cut. And then tool change with center drill to drill the hole.
For the programming, we use the Cinemetry 840D to make the NC programming and simulation. Next.
Alright, now I will give a description of the process of making a product simulator using Cinumeric Cinetrain. First, we use the shop mill to do the simulator process. After choosing a shop mill, we must provide a blank that is the size and the shape of the workpiece that we want to use for this project. After that, we set the program header such as spindle speed, coolant, tool, and or anything else you need to put in program header. After finish the program header, set contour process for the body part of flash exhaust. After make the contour, set the parts milling for roughing and finishing process. The pro after that, the process to make the pocket has two parts, one on the left and one on the right side. To make a pocket, click the milling and then click the pocket button. We choose a tool diameter of size 10 for the tool. For the machine, we choose a centric and single position. The distance for X1, the distance for X0 is 18.11 mm, and the distance for Y0 is 33.06 mm for the left side, while for the right side pocket, the distance X0 is 95.61 mm, while Y0 is 33.06 mm. The total diameter of this pocket is 30 mm, and the Z1 is negative 20 mm. The way to make the pocket process is the same, only the distance XO and YO are different. After that, to make the drilling process, click the drilling and choose deep hole drilling. Pick the drill tool size diameter 8 and then set the feed rate and spindle speed. The deep for this hole is 20 mm. After that, set the deep hole drill. We must set the position of the hole to drill. To make the position, click the milling and pick the position. After that, choose the position style that you want to use. After that, set the distance for XO, YO, L1 and L2. After set the distance, you must set the how much drill that you want in N1 and N2. After settle the drill process, we can make the simulation. This is the simulation when we finish the process. This is a contour process, which is roughing and finishing. And that is the pocket process for the left and right side. And after the pocket process, we make the drill process. That is the top view of the flash exhaust.
For the conclusion of this project, we can conclude that it was a success. Then the usage of CNC programming support systems such as Siemens are very helpful in order to generate the NC code for the simulation. Other than that, when involving more complex shape to be machined, we are using CAD/CAM systems such as CATIA for generating simulation. It was very helpful and also a success. The main objective of this project clearly give a big impact on us so that we can produce the component or part using the CNC machine efficiently. It also can increase our skill and knowledge to operate the machines. That's all from us. Thank you.
All right, thank you.